Well, thanks for coming, everyone. This presentation is going to be on particles, as you can see, but more so to hopefully generate you some ideas of where and how you can use particles in your games. And we'll go through just a small little demo to excuse me, kick one up and show the process of making one inside Unity. Although this is all done inside Unity, concepts will be similar across basically all engines. So let's kick the show off. What are particles? According to the Unity documentation, particles are small, simple images or meshes that are displayed and moved in great numbers by a particle system. Each particle represents a small portion of a fluid or amorphous entity, and the effect of all the particles together come together and creates the impression of the complete entity. Basically, a bunch of little things making one cool thing. The parts involved are the particle itself, which in this example are just the little dots on the screen. And then you have the particle system, which controls everything. So it tells the particles how to move and what they should look like and if any forces are applied to them. Where would you use particles? You can use them for environmental effects, such as rain, dust, clouds. Weapon effects, muzzle flashes, ejected rounds, bullet holes. Fire and smoke effects, let the world burn. Spell effects, so you can do like casting magic, damage over time, visual indicators and buffs and that sort of thing. So you might hear the word effects being used a lot. So particles are pretty cool for effects. So this one here is like a little railgun blast coming through. And you can see, yeah, they've got some ejection as it goes past over time. So you get some pretty interesting things. So local versus the world. Local is simulated using the local object space. What that means is the particle will be controlled and moved according to the matrix of that local object. So up for that object is up, left for that object is left, and so on. World will be simulated using the world's coordinates. So these two are very different. If you mix the two around, you can get some artifacts like this. So the top one is using the local world space, the local space. The bottom's using the world space. And as the particles spawned and as they're created, they're getting created in local space. The other one's getting created in the world space. So as it moves, the local space is always going to be the same for that object. The world space, however, is static, and that will never change. And that's why you get that cool movement effects. And both have their cases. So local use cases would be static effects such as fire in a barrel. So you might have a barrel somewhere, the fire coming out of it. Short-lived weapon effects. So if you shoot a wall, you might have something quickly eject out, or splash effects. World cases would be like steam from a train. So a choo-choo coming past and the steam particle is still being affected in world space. Or ejected rounds from a weapon. So if you're firing a weapon and the player's still moving, you don't want that weapon to sort of be moving with the player. You want that shell to be ejected onto the ground and carry on. All right, so this one here is, we're talking about the shape module for particles. So the shape module will determine where it will spawn and what sort of movement it will have as well. So in Unity we have a few options. These are just a few, not the whole entirety. Give you a sort of effect. Let's bump this up a little bit. Yeah, let's throw a few more particles out there. All right, so we've got a circle emitter at the moment. And we'll turn the speed down so you can see what's happening. So these particles are just spawning, they're not moving now. And you can see they're just sort of in an ellipse, in a circle there. If we change the shape radius, you can see that it grows and shrinks and carries on. We can also change the radius thickness. Why this is handy is so that you can do things like this. And you can combine that effect. So if we give it some speed now, and let the particles live a bit longer so they can move. There we go. So you can sort of see like there's like an invisible force or something there in the middle, and they all spread around that, that radius. We also have a donut effect, which I guess is kind of cool. I can't really think of a reason why you'd want to use it, but I guess it can add some random and chaotic directions to your particles. Boxer shapes as well, I mean, carry on. You can also add your own custom meshes. So if you have a model that you've done up in Max, Maya, Blender, whatever, that can be the controlling shape for your particles. Using noise. Okay, noise is one of my favourite things in the world. So when Unity added the noise system into the particles, I was like, woohoo, yippee. Why this is handy is because who's familiar with what noise, Perlin noise, all derivatives are? Okay, most? Yeah, cool, everyone? Excellent. So we can add noise to affect the particles' positions. And what that would look like is this. So they still have a goal to get somewhere, but it's been affected by noise, so it's getting there at a bit of a wobbly sort of way. Likewise, you can apply that noise to rotations. So you can see each particle is still moving in a direction, but they're just spinning on their way there. And as you can probably guess, size as well. Sorry. And all possible combinations. But this can come really handy for some cool effects. So you might have some magic effects or something where you might have some swirly embers or something. All right, so I'll just run through now a quick little demo on making some snow. What you'll need to do when you think of a particle system is, when you first make one inside Unity, you'll just see some white dots and you'll be like, right, now what do we do? Okay, so you'll have to think of what you want it to look like, what the end goal is going to look like. So for our snow, we know we want it to be affected by gravity. We want them to be billboarded, not be billboarded, so we don't want it to be facing us constantly. We want it to move in 3D space. And we want it to appear to float as well, so as if there's like some sort of wind gusting us away there as well. Also a texture, so we just don't want a white spot. We want to throw something on there. So let's get in and make a particle. And as good preparations go, I have some pre-rendered material here. First up, let's just add our particle system. Effects, particles. And if we look at it, it's like, hey. And you've got to think, like, all these effects that we've seen so far have come from this. And yeah, okay. So yeah, they're interesting to say the least. So what we want to do here is we want to add some snow over this little village. Bring it in there, bring it in there. If we look at our particle system module here, we can find the shape module. Currently is a cone, so in 3D space it's going to be a cone that's going to be ejecting at an angle, upwards and outwards. That's handy for some situations, but not really this one. What we want is we just wanted to find area of space and then have the snow fall down. So for here, we'll add a circle. Again, as I mentioned before, you can have a heap of different shapes just out of the box. Okay, and if we zoom right in, that's our circle right there. So yeah, let's adjust it slightly. All right, so we know we want our snow to fall inside that circle somewhere. And we also want it to fall from the top. Yeah, it looks good right there. Cool. So already we have some particles because by default we have some flying around in our particle system here, but it's not enough. Let's crank it up. So in the emission, at the moment, so rate over time, what this is telling us is it's going to spawn 10 particles per second over this amount of time. So 10 particles isn't really a lot. Let's crank it right up there. So that's looking a bit better. But as you can see, they're sort of moving outwards. It's looking okay, but it's not quite the snow falling. It's just they're moving up in the sky. So we're going to stop their speeds. I'm just going to tell it just to stop. So they're not moving anywhere. And now we want to apply a gravity modifier. So even though they're not moving, they're now going to be having the gravity force applied to them. So as they come down, using the gravity, 0, 1, start to fall. Now you'll probably notice there's a few up here. You can see them slightly starting to fall, but then they die. So we need the particles to live a little bit longer. So their lifetime, we're going to set to 20 seconds. So each particle is going to live for 20 seconds and then die. So that looks a little bit better already. Correct. So we have a maximum particles setting here. At the moment is 1,000. So at any point there will never be over 1,000 particles. If we look down here, it tells us that now we have 1,000 particles in the scene. But if I change the rate over time back to 10, you can see that there's only 200 particles in the scene. But you might be thinking, well, we just told it to give it 1,000 max particles. Why are we only seeing 200? It's because it's working out the maths. So 10 particles over 5 seconds, we're only going to get a max of 200 particles. So we can crank this. Let's type it in there. We can crank this to 1,000 particles per second. But because it's being capped at a max particles of 1,000, it's not going to continue to spawn over time, and that's why you can see the particles there all falling at the same rate. And then they respawn again. So things to take in consideration as well. Yeah, 100 there should be pretty good. All right, size. If we get a bit closer into the scene, you'll probably see that our little snow here, they're probably a bit too big for the scene. So we can have a start size and change it to whatever we want here, 10.1, or we can also set a random range between a curve or two constants. So I like to use the two constants here, and we can say, let's say 0.05 and 0.2. So that's going to give us a varied sizing of each particle there. You can start to see them coming down now. Excellent. Okay, so it's looking pretty cool, but we want it to have that sort of gust as if there's some wind coming through. So that's where we use that noise module that I was so frantic about before. Let's go down in here. So here's our typical Perlin noise. Let's enable this. And straight away you can see that's starting to give us some variance there in the positioning. 2.51. Cool. So bunch of different settings here, but for what I want, this is perfect actually. So this is what I've put down in my notes, and that's going to work quite well. Now the other thing that we want is we want to change the texture of the particles. Instead of being the default particle, which is just basically a ball that's shaded out to fade, we can change the material here to, oh look, I have a few in here already. One called snow. And I don't know why I've made two, but why not? Fantastic. So if I bump that sizing back up a bit, there we go. Cool. However, they're still looking at us like we've done something wrong. They're not sort of floating around in free space. They're very much just eyeballing us. Yeah, exactly. So, so what we need to do there is we just need to change the viewpoint, which is render alignment. So render alignment at the moment is view. So it will always look at us no matter where we are in the view. If we change this to be world, oh, sorry, my bad, not world, we want the velocity. So what that means is where it's facing, it's going to be turning. So its position will be where the velocity of that object is moving to. And we can see that's looking pretty cool. So for now that's going to work. Let's just make sure we can see it out here. Let's make them live a little bit longer so that they actually have time to hit the ground. Now another thing that you want to be aware of, especially with environmental particles, is let's stop this simulation. Now let's start this simulation. So starting simulation is if you just started the game or into the level or walked into the trigger zone or whatever. And simulate. Yeah, that's kind of weird, hey. Now there's a video you can actually look up on YouTube with, I think it's Far Cry 3, where a guy's climbing up over a cliff, he gets up and then there's a really cool looking waterfall and the water just starts to come down. So this is a very important thing. What we want to do is we want to tell this particle system that we want it to be pre-warmed, meaning that it's already going to be applying this simulation as if it's a few seconds in already, so as if it's one cycle in. So we stop, re-simulate, so much better. Okay, so that's something that you really have to be aware of depending on where you're using your particle system. Again, if it's going to be something like environmental effects, yeah, you definitely want to have that pre-warmed. So let's jump into the game and see what this looks like. Cool, I have some really dodgy first-person camera view here. Actually, I might tell you to... Okay, and what I wanted to show you here is that I need to expand my radius to show you what I want. Let's make that 50. Should be plenty. Not quite. But the other cool thing you can do with particle systems is, or particles themselves I should say, is they can be affected by forces. Just moving out here. So forces such as wind. So out here I've created this wind zone. And the demo gods are working very well with me, and as you can see, it's not working. Wait for them to fall a little bit further. Interesting. I did mention I'm not well, right? For our particles to be affected by forces, we need to tell them that they can be affected by forces. External forces, check. All right. That's looking better. So there's a wind zone out here, and these particles are being affected by that. So the moment they get in, they're getting some turbulence applied and they're getting sucked through. So that's pretty cool as well. Like, yeah, it's running better already. Look at that. Hadouken! Yeah, but like, come on, let's be real. Like, unless you're going to fill out like tens of thousands of particles on screen at once, you don't really have that much of an issue to worry about. And you'll see, like in these next few demos, I do get pretty particle heavy, so let's have a look. So, This one here is a cool little game. I think might be quite successful. I might call it Street Fighter. And what we've got here is his little might get in a little bit of trouble. So he's got his little Hadouken blast. So there's a few things happening here, and what we'll do is we'll go and we'll pause. So what's happening is we have the main fireball itself, which is this guy here, and he's got this little trail happening. He's also got like a little sonic blast carving the wind space around him up the top. And he's also got these little cool trail effects happening, so it's like little sparks that come through. If we skip a few frames, we've got the impacts. So over here, as you can see, there's like a little ring that's starting to form, and what will happen is there's a couple of those spawn and they'll come out, and you've got all these little blasts as well that are, I think there's probably 300 in there that's just going to come out from the screen. So I cheated a little bit. This is the exact same texture as the main Hadouken tail itself. So why not? I mean, it's only on the screen for a few microseconds. Back out, we'll let that play through. Cool. So like that's quite visually pleasing. It's eye candy, it catches your gaze. But I'll take a few things off to just show you the impact that will have, especially like with these sparks, those impact sparks as it hits. It's like, it's okay, but it's still not, doesn't give you that same awesome effect. Likewise with the ring, you're just going to have the ball come through. And even the subtlety of that little glow at the start of the ball, you do miss it. Like if you have a look here, it's still cool, but that one's better. Even as subtle as it is, it's still something that adds to it. The tail sparks themselves are really cool, and I'll just turn off the ball and zoom into them. And what I want to talk about here is those little tails that shoot out. They're inheriting the velocity of the ball. What that means in real world speak is the ball's moving this way, and as they spawn, they're inheriting that velocity as they go forward. Now, if you've done any sort of physics in game engines, you can also apply a drag modifier. So as the ball's going this way, you can add a drag to that spark so it slows down and comes to a stop. And you'll see the sparks, they have an initial velocity that shoots out, but they'll slow down. So it gives like a little, like a calming effect to them. And again, that just adds to the overall effect. And of course, you've got the ball itself that has a cool little trail effect as it comes through. And as an unintended but awesome side effect, got this cool little like stretching here with the tail. That was supposed to be straight, but you know what? That looks cool. So yeah, side effects are cool. Why not run with them? All right, so speaking of physics, so yeah, you can apply a rigid body to each particle themselves, and they can interfere with the world just like any other object. So that means they can apply a force, they can bounce, they can move along another glider. So in this example, you can clearly see that there's a flaw here, even without the mesh being rendered. And they've also got a bounce, and they have some dampening. So it gives a fairly realistic effect for a spark that might be coming off this thing here. So new in Unity 2017.1, particles can apply a force to other objects. What that means is you might be able to have like this gun, like a spark gun or something that's shooting out a bunch of particles. Those particles can then move real-world objects. They can push real-world objects that have another collider. So that's pretty cool too, just for using particles. With the physics, you also have the option to die on collision. So if it detects it's collided with another object, it can die. Or you can do any other function, like you might be able to spawn another particle. Or, as it says down here, you can even code a custom callback as it triggers or collides with that other object. So you might have a script that does something cool with either the particle itself or any other real-world interaction. As soon as it collides, bang, it can call that callback and continue on. Rain is probably one of the simplest particles you can make. Like all you have to do here is this is just the standard particle material that comes with Unity. It's applying a stretch, and if we can pause that there, so you can see the rain droplets themselves. There we go. Rain droplets themselves are just that little ball stretched out, and then you've got this splash effect over here. And what that is again, it's just the standard Unity default particle, but it's just doing a little, push out of the center of the system. So as soon as it collides with the mesh, that raindrop is then dying, and it's spawning this other splash particle. So if we keep that, fumble fingers. So if we hide the mesh there, you can just see it's hitting that collider, and as soon as it dies, it's spawning the splash. And again, that's just standard built-in Unity particle. There's nothing really special going on there at all. But do take away the fact that you can stretch particles as their movement increases or decreases. So that's how you get that raindrop effect. All right, spell time. You can combine a bunch of different particles together to make a cool sequence. You can also script particles. Man, you can script particles. Not just the particle system itself, but each individual little particle you can loop through the system and grab and do whatever you want with. For example, I made a little space game once where a particle system was spawned on the player, like on the player ship. Boom, big circle radius, and it spawned, I think it was like 3,000 little particles, and that's your space dust. As you move around, you can see the space dust everywhere. And as you got out of range, that particle would then die and then spawn another one inside that system, inside that radius. So yeah, scripting with particles is cool. It's quite easy to do. So you trigger it all together with some audio, get some timeline action in there, and you can get something like this. All right, and thanks David for the witchy model there. I hope she did justice for you there, mate. So talking about the particles in this little example, I'll talk about the ones on screen right now. You've got the fire effect that's on the witch's dress. What that's doing is that's spawning particles based on her mesh renderer for the dress. So as I was talking before, for a shape, you can assign a circle, a donut, whatever you want. You can also do a mesh renderer for an object. So these particles are spawning on the mesh for that dress, which is cool because it looks like the particles are floating around her body and her dress. There's a second particle system on her skin. And what that's doing is that's grabbing the position of her skin and sort of blowing it out a bit. So it's expanding her there. And as you can see, you can make out her silhouette with the particles up the top. If this was in a real game, however, I would probably be more inclined to do this in a shader, but it's an example of what you can do with particles. And then, the other things like the fire effects and that sort of thing. So you might have seen the fire ring start and sort of circle around. That's an example of where you can use the particles being in world space rather than local space. So as the shape moves around in the circle, the particles are spawned in that world space and they're staying in that world space. So combine them all together, you get a cool little effect. Yeah, good model there, mate. Yeah. we got her in there. It took us a while to get her in, but we got her in. All right, cool. So another example would be a supernova. So we sort of all know the first few words here of the Big Bang Theory song. So everything here is particle. The stars that are coming out from the centre, all they're doing is they're just changing their size over time, and they've just got a random colour going. So some have got a slight blue tint, some are white, You may see in the bottom corners that it's a bit more obvious with the blue ones here. We've got the space dust. Space dust is pretty cool. It's obviously using that circle shape that I was talking about before. But what it's doing is it's still spawning from the very center, but I've capped a limit of where the alpha, so the transparency on that particle, should be over its lifetime. So that particle starts in the center and it zooms out. So as it hits about 50% of its lifetime, it then becomes visible. And then the last, I think, 75% of its lifetime, it's told to limit its velocity. So that's why it's still not moving out. It's sort of staying there at that center and continuing to burn, I guess. Streaks are pretty simple. That's just the standard Unity particle, but stretched. So I've turned off the standard renderer for it and turned on trails. And as it moves out from the center, it's creating a trail effect as it goes through. And again, that's just got to fade in and out over time as well. And then, yeah, you've got the dust in the middle that has this cool little cosmic effect there. Particles and lights. Now, this is really cool because not only can your particle cast shadows and receive lights, but it can also cast lights. This example isn't casting any, but it's just showing the shadow is. However, for your particle to receive light and cast shadows, the shader it uses must also receive light and cast shadows. So the standard shader for particles in Unity does not. So you might be having this awesome particle system ready to catch some light like this, and you're pulling your hair out, you go, oh, why has it not got light, or why is it not casting the shadows? It's because that shader is specifically told not to do that. So it will need to have, I think it's a geometry tag in the shader, or just use some of the other default ones. I think this one's just using the vertex lit standard diffuse. To cast shadows, you need to enable the option in the renderer. So it's just particle system, renderer, cast shadows, turn on. And there you go, it looks pretty cool. Again, my friend fire, let the world burn. It is very cool to combine shaders with particles. As you can see here, we've got this fire. It's burning the paper. The paper has a shader involved which sort of diminishes the paper, so it sort of burns it, and it has this like burn edge to it as well. So it's a cool little shader I can't take credit for. I stole it off a Unity talk, but I thought, you know what, that's perfect for this example. However, you look at the shader, honestly, it's probably, I don't know, 25 lines or something. It's not involved. Like, you can write this. It's not a tricky shader. It's just knowing what you want it to do, knowing what your end goal is, and then working towards it. But the cool thing is with particle systems, you can add custom data into the shader. So here you've got custom data. So this is in the particle module. It's probably a bit blurry up there, sorry, but it's just custom data here. And we add, we add a component here for X value, which is just the time. So lifetime of the particle, it starts at 0, gradually gets towards 1. We have a color, which is a HDR color, which is really cool to work with HDR colors if you haven't already. Try it. And then we're passing that into the shader. So what we want the X coordinate for is the lifetime of the particle. So we know how long the particle is for, so how far we burn that in with the shader. The color, and why it's HDR, is so that we can pass that into the emission, so it makes it look like it's burning those edges there. And yeah, to access them, it's just like you access any other property inside the shader. Just declare it here, quite simple. This example here also shows, with the smoke here, catching light from the fire, which is a cool thing with the with particles, how they can accept light. So it makes it look like a very volumetric sort of smoke. And it's just a cheat, it's not real. All right, and the final piece here, get grayscale. All the particles are going to be a grayscale of some type. just experiment with them. Like, you'd be surprised what you can do with a simple texture. So everything in this example, I've made myself apart from that burning page. And as you can see, some examples here, like they're quite basic shapes really. And you just put them in and use your system. So this example up here is using the light spawning system. So particles can emit lights. However, as you may know, by default, your shader can only handle 4 lights at a time. You can bump it up inside the engine, but let's not do that for performance sake. So what I've done is I've added an exact duplicate of the same shader, the same particle system, but have limited it to only to be 4 particles, so that it can spawn that light with that particle, and we don't have to worry about the clipping of the lights. So it's the exact same noise as you can see the little trails that come through here, and yeah, it gives a very convincing effect. So let's add some bloom, baby. You never have too much bloom, can you? We'll just spin around here. And again, we're talking about local space versus world space. And hopefully you can see it on the screen up here. Here we go. So you can see those tails there. Yeah, so, I mean, that's, like I said, if I can make this in the span of a couple of weeks, with about, 20 or 30 different particle systems, well, you guys can do some pretty awesome work. So just have an end goal of what you want it to look like. Because if you look at it at the start, it's just a couple of white spots coming out of the ground. It's like, well, okay, what are we going to do with this thing? So you sort of want to have a good, clear goal of what you want it to look like. All right, very good. Done. Anyone else got any questions? You're just blown away by David's model, really, aren't you? That witch just took the show. Yeah, this one was pretty cool. Hey, like, I thought, Portal was a pretty cool game. What can we do with that? Yeah, those little trails that come out the end, they look pretty sweet. It's a good thing to do because, let's be honest, we like to copy and cheat and take shortcuts wherever we can. So if you're going to do a session where you're going to experiment with particles, set yourself a couple of hours, sit down and make some cool stuff. Save it as a prefab and use it later. Like if you're like, oh man, that looks really cool, I'll use that later. Do it, save it, put it away. Like when I started doing this, I didn't think I'd be making a portal thing, but I was sort of like, oh, what else can I do? Like, yeah, that'll be sweet. So like those little tails that coming out of there, I'm definitely reusing that somewhere else because they look cool, man. Yeah. And yeah, like so with the textures as well, even though that they're so simple, the way that you use them is important. Like this portal one here, down here, it's pretty dark. I might turn the directional lights off, might be a bit better. No, sorry, I thought it might have been a bit too dark, but you get the idea. This texture here is used for the portals, but they're layered on top of each other, I think, 5 times, and they're rotating as well as fading in and out. So it actually looks like they're animated, like it's an animated portal. But just because the alpha's changing, sorry, they're not actually rotating over time, they're just spawned at different rotations. And because their alpha is changing, so their transparency is changing, it looks like it's rotating and animated. Yeah, which is really cool, especially with the orange one on the side as well. It doesn't really help perspective. Yeah. Yeah, they're cool. They look really cool. And again, like using the lights and using shaders and normal maps and everything. Like this background, that's just flat, man. Like there's nothing else to it. It's just got that normal map on it. It makes it look really cool. I'll get while the lights, about there. Yeah, it really gives it that extra dimension. Oh, magic effects, like seriously, like put that on the hand of someone. Like with the witch, I was hoping that we could do some sort of movement like this and have these streaks come out of her like that as well at the same time. So picture those on her hands. Yeah, it would look mint.
Actually, this is more a question than anything. Like the first scene that you had, was that with Winterfell? From like
No, I just went on Asset Store and just said, what did I look for? Village scene or something, I think, and that was the first thing that come up.
Like, I've been watching Game of Thrones like a lot.
Yeah.
It looked like the castle.
Yeah, no, I think it was, I was like this one.
You're in the snow there and like winter is coming.
Yep. Yeah, I mean, yeah, I totally planned that. I don't watch Game of Thrones, but yeah. Cool. All right.